The first thing I want to do is to just spend a few minutes going over something everyone in the audience knows, which is what are the challenges of cancer? Cancer is a very challenging disease for a number of reasons. First of all, it's not one disease. It's 250 different diseases that we have to deal with. Secondly, from a population health perspective, it's a big challenge because it's become such a prevalent disease. I also want to discuss some historical considerations because that helps us understand what we need to do in the current environment with a cancer institute or a cancer center. So we have to understand where we were, how we've made progress up to this point, where we are now with cancer as a disease, but where we need to go. We don't want to set up a cancer center that is appropriate for 2014. We want to set up one that's appropriate for 5 and 10 and 20 years from now. And then there's always financial considerations to think about. I won't go into that in any detail because our system is quite different than yours, but there are always considerations of how you fund the various activities. And then of course I'll give you examples of both how cancer centers have been set up in the US under the direction of the National Cancer Institute there, and then specifics about the Duke Cancer Institute. So why is cancer so challenging? As I mentioned, first of all, it's many different diseases. And in addition, it's a disease, it's a group of diseases that increases exponentially with aging. That means a lot of the patients that we're treating are in the last 10 or 20 years of their life. Many of the therapies that we've developed, especially the cytotoxic therapies, are very difficult for elderly patients to tolerate. So you can't just have one set of treatments for even for a given disease, because the age of the patient may dictate how you can intervene. So you have to take that into consideration as well. There's also biology that is a big challenge in cancer. And these kinds of things do impact on how we set up a cancer center. So if you think about a tumor mass the size of my fist, maybe 50 billion cells in that tumor mass, you have to get rid of 100% of them. If you get rid of 99.9% of those 50 billion tumor cells, you still have millions of tumor cells left behind. Tell me another disease where you have to be 100% effective in order to have a cure. It's very, very challenging from that perspective. So we can't simply be 99.9% effective. We have to be 100% effective, and that's why multimodality therapy is so important. You have to combine the surgery with the chemotherapy, with the radiation therapy, and have very exquisite and technologically advanced diagnostic imaging and an ability to detect small numbers of tumor cells. Another reason cancer is a tough disease, and you all know this, is cancer is us. It's not some alien that's invaded our body. This is our own cells that have been modified, and therefore when we develop therapies, we're trying to kill some of our own cells in our body, which is a challenge. I mean, I could get rid of every tumor cell in every patient by irradiating the patient to 12,000 rads. There wouldn't be a tumor cell alive. Of course, the patient wouldn't survive. So we have to develop our therapies in such a way that we are able to selectively kill the tumor cells and not the normal cells. But then the tumor cells have an inborn advantage. Part of what makes them a tumor cell, what makes them grow in their endogenous environment, is that they've developed mutations that make them not die. The same mutations that make them a tumor mass that continues to grow because they've forgotten how to use the normal death signals are the same mutations that make those cells not die when we give them chemotherapy or radiation therapy. So biologically, it's a very tough problem. And then we face the issue of not only do we have 250 diseases, but even when you have a given disease, you have non-small cell lung cancer mass, you have tumor heterogeneity to deal with. So you have dozens of clones within that tumor with different mutations that you have to think about in treating. And so with targeted therapies, this is turning out to be an extraordinary challenge for us going forward in developing effective therapies. How do you develop a therapy when 1 million of the cells have this set of mutations, another million have this set of mutations, and it's very, very difficult to develop treatments that attack all the different tumor populations. And then, of course, you've got the issues of tumor microenvironment that The surgeons know all too well, but so do the chemotherapists, that you have changes in blood flow that limit how well chemotherapeutic agents get to the tumor, and of course there's the evasion of the immune system. And in fact, this is one of the most exciting things in the field right now, is we're learning ways to trick the immune system to come back on and recognize the tumor cells. And this is turning out to be, now that we're learning how to turn the immune system back on, more effective than anyone would have bet 2 or 3 years ago. So again, in thinking about how one positions a cancer center to be doing research and patient care protocols that are this generation and next generation, you have to understand this biology to be able to do these types of therapies. Immunotherapy, it has to be a part of every modern cancer center now, just because of changes that have occurred in the science of cancer biology in the last 2 years. I don't have the data for the population challenges in Singapore, so I'll give you the data in the US. I'm sure it's not terribly different in terms of some of these numbers. So in the US, just in this year alone, 1.7 million new cancer cases. 1 in 2 men and 1 in 3 women will develop cancer in their lifetime. It is truly a public health problem. And even for those individuals who don't develop cancer themselves, everyone has a family member or a close friend who develops cancer. So it affects everyone in the population. So this is something we also have to think about, is we're delivering it. We think about it as a specialty disease, as a specialty center, but in fact, it is something that affects everyone in the population. And the number of new cases, at least in the US and probably worldwide, is continuing to go up significantly. And part of the reason is, as we cure other diseases and people are living longer, and since cancer is a disease of aging population, the number is going up significantly. In the US alone, almost 600,000 deaths from cancer this year, but we also have 14 million cancer survivors. And it's wonderful to be able to talk about cancer survivorship, but we have challenges with our cancer survivors, because the ones who have survived now have other health problems that we've given to them through the chemotherapy and radiation therapy and surgery that we've done. And so that's something that, again, in a comprehensive cancer center, you have to be able to take care of those patients after you've cured their disease. So again, one of the problems we face when talking to the lay public or talking to our politicians about they need to give us more money in order to do research and to take care of our patients, is they say, well, you should have cured the cancer problem years ago. Why is progress so slow? And so I frequently like to show this cartoon from Gary Larson that says early microbiologists, these cavemen looking through their hands at rocks. I said this is the stage we were at least in 1971 in the US, when we so-called declared the war on cancer, when the National Cancer Act was passed. We didn't have the knowledge base to even know what the disease was. We didn't understand what it was we were trying to treat. And we didn't have the technology to answer the questions or to develop new therapies. So we were very naive 40-some years ago, when everyone thought that we were going to have this war on cancer. But in the last 40 years, there's been tremendous changes. We've learned a tremendous amount about what's the difference between a normal cell and a cancer cell. So now we have all the genomics data and proteomics data, and we have the biology and understanding how a tumor cell is different than a normal cell. And we're in the midst of a real revolution, because by understanding the biology, we're able to develop new therapies that are not simply toxic and killing the tumor cells, but in fact, trying to kill the tumor cell in the way that it's different from the normal cell. So we all feel this very palpable excitement in the field. Things are changing, whether it's immunotherapy, whether it's targeted therapies, whether it's the ability to use nanoparticles to deliver chemotherapy. A lot of changes are occurring rapidly, and again, the only reason I'm going through all this is because as one thinks about setting up a state-of-the-art comprehensive cancer center, you have to be poised to do all those kinds of activities. So we've made a lot of progress, even without having these fancy approaches that have just developed in the last several years. 80% of all children who are diagnosed with a malignancy will be cured of their cancer, and 2/3 of adults, at least in the US, will live at least 5 years after a diagnosis. But as I've said, many of those who survive will have short-term and long-term toxicities from their therapy. So again, a comprehensive center not only is is focused on developing both more effective and less toxic therapies, but also on the taking care of the short-term and long-term toxicities of those patients. So that's the disease challenges that we face and the kinds of things we need to think about in setting up a state-of-the-art comprehensive center. What are some of the lessons we can learn from what the National Cancer Institute in the US has done since that National Cancer Act was passed in 1971? So when that was passed, they developed the Cancer Centers branch of the National Cancer Institute, where the goal was to set up centers around the country, all set up at the time in either freestanding institutes or in university settings where a lot of cancer care was delivered, and to support structures that allowed research, excellence in patient care, training and education, demonstrations of technologies, and cancer control, which means prevention approaches. And then in 1973, they actually initiated what all of us are now so dependent on, which is what we call the Cancer Center Support Grant. So these are NCI-supported grants that go to these institutes or cancer centers that support infrastructure. And there's two types of centers in the US. There are comprehensive and specialized. The comprehensive centers do long-term multidisciplinary programs in biomedical research, clinical investigation, training, community-oriented programs in detection, diagnosis, education, epidemiology, rehabilitation, and information exchange. Everything you can think of that would impact on a cancer patient is supposed to be part of these comprehensive centers. The way these grants work, they're typically somewhere between $1 and $10 million a year, and they don't support research. Okay, this is a common misconception. They don't support the project going on in my lab to understand how radiation therapy works. What they do is they support infrastructure, administrative infrastructure, and research infrastructure that allows and facilitates people to work together. The awards are intended to foster interactions between basic laboratory, clinical, and population scientists, and to give access of investigators to shared services and technologies that are necessary for the research efforts. You don't want to have every investigator have to do their own DNA sequencing or genomic sequencing or proteomics. These grants are supposed to support these shared services so that everyone within that cancer center can take advantage of that activity. And the way the grants are funded, it's a very competitive process. Every 5 years we go through a hellacious period of putting together a 2,000 plus page grant. We submit it to the NCI. They then send a team of 25 people or so to do a site visit, and we have to convince them that we're worthy of continued funding for the next 5 years. So it's a very competitive, merit-based award from the National Cancer Institute. There are currently, actually, this is an old slide, there's now 68 NCI-designated cancer centers. Again, they focus on basic population sciences and clinical sciences. And the way you become a cancer center is you have to do 2 of those 3. Okay? You don't have to do all 3, but whatever science goes on in those areas, basic, clinical, population, they have to interact with each other. And the cancer centers that have clinical activities, not all of them do. Like MIT is a cancer center, the Salk Institute is a cancer center. They have no clinical activities. They do just basic research. But the ones that do clinical research are supposed to participate very actively, not only in doing their own clinical trials, but also in the National Cooperative Group clinical trials. Comprehensive cancer centers are yet another level within the Cancer Center program, and there's 41 of these in the country. And here, you have to have all 3 types of research: basic, translational, or clinical, and population. And you have to have depth and breadth in all 3 areas. In other words, you can't just have one person doing epidemiology. You have to have a whole team of people. And all of these groups have to work together. So again, the common theme is interdisciplinary, multidisciplinary activities. In addition to the research, you have to demonstrate professional and public education and dissemination of your clinical and public health advances into the community. So this is also not something typical of NIH grants, where you have to demonstrate that you're interfacing with your community and the research that you're doing is positively impacting on the community. And so the Cancer Centers program was designed both to enhance scientific discovery and facilitate the application to the patient population, and to facilitate transdisciplinary research activities. A lot of these slides that have a lot of words, I'm not going to read them all, but I know you're going to keep copies of it, so if you ever need to go back and see some of the details, I'm trying just to hit some of the highlights. But it's also important for the Cancer Center to demonstrate that these activities decrease cancer incidence or mortality in your catchment area. This is a very challenging thing to do. We just went through our core grant renewal this year, and we had to convince the site visitors that the breast cancer research that we do is having an impact in the community, and that we specifically focus on the types of breast cancer that are important in the Durham area and in North Carolina, that we work on smoking-related cancers, because smoking is a big issue. So you have to show that there's a link between the science that you do and the public needs. And for comprehensive designation, they also you have to demonstrate that you have these dissemination strategies that not only affect the general population, but also underserved populations. So those who don't have access to great health care, minorities that have special health care needs. That's something that's a big issue in the States. I don't know how much of an issue it is here in Singapore. I know you have several different ethnic populations, and I don't know how much the government focuses on how healthcare is delivered or the special healthcare problems of the different populations, but that creates another level of challenge for us in terms of the clinical trials that we're doing. We have to make sure that the trials have enough minorities enrolled on them, and that the trials, in fact, are geared towards some of the special problems that the minorities have. As I said, the funding is not to fund research per se, but to fund infrastructure, and I'll give you some examples of that. But that funding of infrastructure is then supposed to facilitate how the Cancer Center does its activities in combination with its other income streams, from patient revenues, from philanthropy, from other grant sources. It's supposed to make you more effective at getting those other funding sources to do the research. Sometimes it works well, sometimes it's a little more challenging. But again, what they really are interested in are these vigorous interactions between the different research areas, that you demonstrate collaboration between laboratory, behavioral, epidemiologic, and clinical scientists. This is sometimes a challenge. How do you get a basic scientist to interact with an epidemiologist doing population science? There actually should be a lot of interaction, but sometimes they don't live in the same world. So the kinds of programs that we put together that I'll describe in a second are meant to bring together those various scientific interests. The way cancer centers are put together is they're organized around what are called research programs that are supposed to be either discipline-oriented or disease-focused. They're supposed to be very highly interactive, with exchanges of information between the different individuals, exchanges of experimental techniques and ideas that enhance the productivity of the scientist. And the way they facilitate these interactions is through meetings, seminars, retreats, developmental funding. So even though they don't fund research projects per se, they do allow the cancer centers to have a certain amount of money that they can use to fund pilot projects, to develop new directions. So that's a very important part of what the Cancer Center does. And we have some of our developmental funds that we use from our grant, we specifically allocate to collaborative projects between people in different disciplines, so that we will stimulate those kinds of interactions. And the program members can do any number of things. They can do basic research, they can be involved in the education mission, in the dissemination to the community, or in clinical investigation. And the goal is for all of these individuals to work together. In addition to infrastructure, the other thing that these grants support are shared resources, and I can't overemphasize how important this is to our functioning. So the shared resources provide access to technology services and scientific consultation that enhance interaction and productivity. These are things that are so technically advanced that it would be, unless you work in that specific area, it'd be difficult for you to do it. So if in my laboratory we're asking about what proteins a particular kinase phosphorylates, I can go to our proteomics unit and give them the samples, and they'll run it, and I don't have to learn all that technology from scratch, and it really facilitates the research activities. And virtually all the shared resources have their funds flow from a combination of things, from the grant itself, institutional support, and then they charge a certain amount for their services, but it's subsidized, so they don't charge the full amount to the investigator, which is a big benefit to them. And then the primary users of those shared resources have to be the cancer center members, so they either have priority or they pay less for the use. So that's basically what the National Cancer Institute expects out of cancer centers. What lessons have we learned about the Duke Cancer Institute? So it's a relatively young institute. It was formally launched in November of 2010 as a major initiative to advance Duke oncology care and research. And it was meant to be, and it is, a single entity that integrates all aspects of cancer activities in the Duke University system. It aligns and integrates patient care and research with the goals of improving patient outcomes, decreasing the burden of cancer, accelerating the science, balancing all three missions, clinical, research, and academic, optimizing return on investments. This is not something you typically see as a goal, but that's an important thing, that if we start new programs with this structure, we expect it to have positive impact on our patients, positive impact on our ability to generate philanthropy, and our ability to do better science. Its goal was to improve alignment and efficiencies by allowing us to integrate and collaborate across all the different disciplines, and I'll talk a little bit more about that in a second. To enhance our responsiveness to the changing environment. So for example, as immunotherapy becomes something that every cancer center has to be involved in, we're well positioned to immediately put that into our system above and beyond what we were already doing, because we already have the basic immunologists as part of the Cancer Institute, we have the clinical investigators, we have a GMP facility. These are all things that are necessary for doing modern cancer immunotherapy. It has allowed us to be more effective at philanthropy. Importantly, it helps us with our leadership structure, that we have a single individual that can represent all the cancer activities throughout the Duke University system, so that I can advocate for cancer activities, whether it's with the Chancellor's Group, or whether it's with the entire university, or whether it's with the School of Medicine. So it's been a big boon, instead of having different people representing different fiefdoms having to advocate. And it also provides a foundation for new partnerships, not only across Duke, and I'll give you some examples of that, but also across the Research Triangle. So we're in the midst, in North Carolina, in the midst of several universities and biotech and pharma, and this allows us to have a single representation of all cancer activities when we're negotiating with these academic and university and commercial entities. So the Duke Cancer Institute is a single administrative structure that oversees all cancer-related activities, from basic research to translational research to clinical research to patient care to community outreach to global cancer. That's all part of one structure, and it's all integrated within our system. And the goal is to make it much easier to take discoveries from the laboratory to the patient. And in addition, just as the Cancer Center was opening, the Cancer Institute was being created, we opened up a new clinical building. And this is not a trivial issue, because this building allowed us to create multidisciplinary clinics. So if you have breast cancer, you go to the second floor clinic in this building, and you'll see the surgeon, the radiation oncologist, the medical oncologist in that clinic. You see all of them together. You get your imaging there. It's not like, you have to go somewhere to see the surgeon, somewhere else to go to see the medical oncologist, somewhere else to get your radiation therapy. It's wonderful for the patient. It's also wonderful for, because it's so much easier on them and their family, but it's also good for both patient care, where the physicians actually talk to each other instead of send each other emails or phone calls about what they're thinking about. And it's also good for clinical research that's multidisciplinary. And this building has really been a boon to our ability not only to take care of patients, but to provide multidisciplinary care. So the vision statement for the Cancer Institute is that it would transform cancer care through innovative research, seamless integration of academic and clinical missions, and compassionate care with hope, healing, and cure. We could all say that that's our mission in doing cancer, but in fact, we're able to do that because of our structure, I think, more effectively than most. The initial commitment from the institution to create the Cancer Institute was approximately $60 million of due funds that was available for new initiatives. When I say new initiatives, this is mainly for faculty recruitment in targeted areas. And so in my first 2 years, we were able to recruit 30 new faculty across various disciplines. Before that, it was very challenging to recruit faculty in an academic environment, so this has been a big boon to that. The initial investment's not nearly enough, so when you start a cancer center, you better make sure that you have an ongoing funds flow to keep things going. So we actually have a relationship with our health system so that our success to their margin feeds back to us with a certain ratio, so that there's an ongoing investment that we can then continue to reinvest to continue to allow success. As I mentioned, we have the new outpatient facility, some more laboratory space, and then investment in certain particular areas such as biobanking and informatics that really facilitates translational research. Let me take a step back and sort of tell you the history of where we were before the Cancer Institute was created. So Duke was one of the original 8 National Cancer Institute comprehensive cancer centers. The DCI was created with this administrative structure, for the first time having direct responsibility for all patient care. So we have 1 foot in the health system and 1 foot in the School of Medicine. And so all the medical oncologists, radiation oncologists, surgical oncologists are in the Cancer Institute, and all their salaries come through the Cancer Institute, of course in collaboration with the departments, but that way they feel like the Cancer Institute is their home, and they function in their disease groups as much or more as they function within their departments. Privilege of being selected as the first director of the DCI and started in August 2011. So because of it's such a powerful structure, we were able to make a lot of changes in the first few years. Among the changes, one of the reasons the changes were able to be done was because I was immediately put on all the major committees of the institution. So again, I can't overemphasize the importance of being in a position where you work with the administrative groups that are making various decisions, whether it's where patients are being seen or how different specialties are working together, but how the health system is working in general is an important part of how the DCI is working. So to have our representation there has been a very important part of our success. So again, if you're creating a new structure, I thought it might be instructive for me to tell you sort of what our priorities were in setting up the DCI. So as I mentioned, I started in 2011, and immediately we set up a series of committees that I'll mention to you in a second. We totally reorganized our cancer center programs, and the first thing that I invested in heavily was clinical research infrastructure. All clinical research infrastructure for cancer is centralized within the DCI. So whether you're a surgeon or a radiation oncologist or medical oncologist, we provide the data managers and research nurses that support your clinical research activities. You don't have to go out and find your own people every time you want to do a new trial. We provide that infrastructure. We prioritize our trials because otherwise you could open up hundreds or thousands of trials that are not going to ever accrue patients. We do all the monitoring and auditing, so we take as much of the burden off of the investigator and doing their clinical research as possible, which allows them to spend their time doing the things they should be doing, which is taking care of their patients, writing the protocols, and enrolling the patients on their protocols. We also very quickly set up an Office of Health Equities and Disparities to address this issue of how we interface with the community. And as I said, the new Cancer Center building was open. In my first year, I recruited a deputy director, an individual who had been a director of another cancer center, Steve Paterno, who brought expertise in certain areas that I was not expert in. This is also a very important thing. You want to have a leadership team that's complementary, and Steve brought real expertise in public policy, in cancer and the environment, in population sciences, in health equities and disparities, in patient navigation, which is a very important part of how we take care of our patients, and to have someone focus on all those areas has facilitated a lot of activities within the DCI. And then, as I mentioned, we also centralized a lot of activities to support the research of the DCI investigators, not just the clinical research, but but also the translational research. So we centralize biobanking. So we now, in collaboration with the Department of Pathology, every time a patient comes in, there's a set protocol for how their tumor is collected and biobanked, and can go right into patient-derived xenograft models, can go right into have their DNA and RNA and protein collected for sampling, and this is all collected with all the clinical data is linked. So it facilitates the research of all the disease groups, as opposed to each one having their own freezer of samples where when they think of a question to ask, they'll ask it. We provide all that as infrastructure, and it makes the research work much more effectively. We recruited Qingyi Wei from MD Anderson to head up our population sciences group, and this is also a very important part of, as I mentioned, of what the NCI expects out of cancer centers, that you have population sciences well integrated with your basic and translational sciences. And then last year we were very fortunate to recruit a world premier medical oncologist, Jim Abruzzi, to be our Associate Director for Clinical Research, an expert in pancreatic cancer. I think he's coming to visit here in February. But again, brings a tremendous amount of real strength in clinical research. So how we started things was to say, okay, we're first recruiting leadership. So myself, the Deputy Director, the Associate Directors, Health Equities and Disparities, Director of Biostatistics and Bioinformatics, again, to lead those sorts of efforts for everyone's interest. Global Cancer, so Nelson Chow is now the Director of our Global Cancer effort. I don't know if Nelson has been to visit Singapore. He's also the head of our hematologic malignancies and stem cell transplant group. And he's absolutely extraordinary, and it's a very important part of the research that goes on in the DCI. And then a lot of efforts that have been successful in both recruiting and retaining faculty because of this DCI structure. As I mentioned, it was important for me and to be successful to be well embedded within the Duke leadership structure, so I reported directly to the head of the health system and the dean of the School of Medicine, but in actuality, I really reported directly to Victor Zhao, who is the chancellor. He's since stepped down. I haven't heard yet whether they've announced the new chancellor. We're waiting any day now to hear that. But again, that puts me in a direct role, in a direct interaction with the leadership of Duke University and Duke Medicine, so that the DCI can be well integrated into all the activities of Duke Medicine. We have a number of committees that help us continue to head in the right direction, including, very importantly, always an external scientific advisory board. So this is a group of very senior individuals from around the country that come meet with us once a year and go over our programs and our activities and give us advice. About half of them are directors at other cancer centers, and others are prominent scientists. We have a couple of other committees that I'll mention in a little more detail. We have a scientific review committee, and this, again, is very important for our success. When we do fund pilot projects or decide ahead in particular scientific directions or nominate individuals for various awards, I didn't want it to be my bias in choosing where to spend those monies or to just give it to my friends. I wanted to have real scientific peer review for every decision that's made within the DCI. So we have a standing scientific review committee that reviews all pilot project applications. We have 2 requests for applications every year for these pilot projects. And so we have real competitive scientific review. A typical round would be we'd have 50 or 60 applications, and we'll fund between 5 and 8 pilot projects. So it's very competitive, but it's also very helpful to individuals in the very tight funding period. We also have a committee, our Shared Resource Oversight Committee, that looks at all of our shared resources, our biobanking and our flow cytometry and all the different proteomics. And what this committee does is meet every other month and review how well our shared resources are working. They will make recommendations about new shared resources, a new technology that we need. And again, so we get broad input and have good peer review oversight of how these committees are functioning. Our leadership committees within the DCI are a steering committee, which is myself and all the associate directors in each of the different areas: population science, clinical science, basic science. And this committee mainly focuses on strategic oversight, make sure that we know what's coming down the road so we can plan appropriately. For example, to say immunotherapy is an area we need to be stronger, so we decide to recruit. This is that strategic committee that makes those kinds of decisions. And then we have an executive committee that's basically the steering committee plus all the program leaders, the leaders of all the programs that I'll mention in a second. And this group actually, on an ongoing basis, reviews all the programs and shared resources to make sure that they're doing what they should be doing. And then perhaps the most important committee is our administration group. So since we are responsible for all the patient care and we're responsible for all the research, both clinical and basic, we have one administrative structure that oversees all of them so that they remain well integrated. And this has been extraordinarily important for our success and for our integration. And then I mentioned sort of the unique thing about the Duke Cancer Institute, how it's different than other cancer centers, how it's different from the way the Duke Cancer Center used to be, is that we have a professional services agreement by which all the faculty that deliver clinical care to cancer patients are paid through this professional services agreement. So instead of having their salaries come directly to the departments, this is an agreement between the health system and the faculty practice plan by which their salaries come through the DCI. And in this way, we can help influence what their activities are. And we say it's important for the surgical oncologist that does mainly GI cancers to integrate with our GI medical oncologist, with our GI radiation oncologist, and they feel part of that disease team as much as they feel part of the Department of Surgery, and that's been a very important part of our success. And you can see the 13 disease areas through which these salaries are paid. We have 9 programs. I'm sorry, the numbering got a little changed in this, but we have 9 programs within the DCI. We have 2 basic science programs, tumor biology and molecular genetics and genomics. We have a population science program, cancer prevention, detection, and control. And then we have 6 translational programs, 3 of which are disease-focused. Brain tumors, women's cancer, which is breast, ovarian, and we've added thyroid to that because that's largely a women's cancer and has a lot of scientific overlap with breast and ovarian. And then we have hematologic malignancies and cellular therapies. And then we have 2 programs that are discipline-focused, radiation oncology and imaging, where there's a lot of interactions between what our radiation therapists do and what our radiologists do, so that's one program. And then developmental therapeutics, which is basically all issues of drug development, from structural biology to chemical biology to preclinical models to biomarkers. And then we have a new program, it's no longer a developing program, this is an old slide, that we call solid tumor therapeutics, which is all the other solid tumors that are not brain tumor or breast cancer. And we put these into one program. So this is GI, GU, lung, head and neck, melanoma, sarcoma. And you might ask, how do all these fit in one program? They're all such different disease areas. And the way we do this is within this program, each of the disease groups do meet on their own, but they work together in the sense there's a lot of commonalities. There's commonalities in determining biomarkers, there's commonalities in targeting signal transduction pathways, there's commonalities in animal models, there's commonalities in immunotherapy. So there's a lot of interactions between these disease groups where they benefit from working together within a program. And then, as I mentioned, the shared resources, I won't go through the entire list, but things like flow cytometry and our transgenic mouse facility and cancer genomics, our biorepository, bioinformatics and biostatistics and so on. And then we formed a number of other offices that help us do some of these other community activities, including this Office of Health Equities and Disparities. I'll mention in a second our Center for Cancer Survivorship. We have an Oncology Nursing Center of Excellence, Global Cancer, Cancer Health Policy, where we have a group that actually works with both local and federal elected officials to help drive cancer policy, which is not a trivial issue for us. And then we have our very important development office to help us with philanthropy. And as I'll mention at the very end, that's the only way we can make ends meet really in the current financial environment, is to have additional philanthropic input. We also have worked very hard to take advantage of the richness of the Duke University atmosphere where there's a lot of different departments and schools that we interact with. We have a lot of interactions with the Division of Cardiology that I'll mention in a second, with the Duke School of Nursing, with the law school, with the School of Engineering in developing nanoparticles, the School of Public Policy in trying to study and influence public policy related to cancer patients, with our chemistry department in terms of chemical biology and drug development, and with the Nicholas School of the Environment in studying cancer in the environment. And for example, we've set up a cardio-oncology program to focus on the many side effects in cardiac metabolism and metabolic disorders that occur in cancer patients. And this is a collaboration between the DCI, the Heart Center, our palliative care group, and our Stedman Nutrition and Metabolism Center. We have an oncology nursing center of excellence with our nursing school that facilitates both nursing research as well as patient care activities. And then something that we just started last year and is growing very rapidly is our Center for Cancer Survivorship that has focus on both clinical services, support services for patients and their families, as well as research activities. And this is becoming a more and more important part of a comprehensive cancer center activity. I wanted to briefly mention our focus on doing translation and all the different components that we put into place that allows us to do translation of basic discoveries. So basic scientific discoveries can occur in any of the programs that I mentioned. But then we have specific expertise in chemistry and structural biology and in biomarkers to be able to develop targeted therapies. As I mentioned, we have centralized tumor banking and genomics and tumor grafts. So when we take the tumor out of the patient, and we bank it, we also frequently will take that tumor and put it right into a mouse and develop these patient-derived xenografts, which we then will store, and when someone's ready to do some studies on those, they can take them out of the freezer and have these patient-derived xenografts for testing their new targeted therapy, because we already know the genomics of that tumor and which mutations are there. So it really allows us to do targeted drug development much more quickly. We have an immunotherapy working group that allows us to develop and test immunotherapeutic approaches, a GMP facility for the development of biologics and vaccines. We have significant research in preclinical and clinical imaging. That's very important for both preclinical studies as well as our clinical research. We have within our clinical research infrastructure, biostatisticians are embedded in each of the disease groups, so they help design the protocols. So it's not like the protocol's designed and then after the fact we're sitting there saying, okay, how many patients do we need to do this study? That will have been worked through right up front. We have a phase 1 group, so that are independent of what disease the patient has or what disease group is doing the particular study. The phase 1 group can help run that study, has all the infrastructure for the IND development and doing the phase 1 clinical trial. We have a lot of developmental funds that are specifically supported to do projects, because these kinds of clinical trials are hard to get funding for, so this is one of the things we use our pilot projects for. We have infrastructure to allow us to do our own INDs and regulatory oversight. And then we have a big effort in outcomes research to know when we do large clinical trials or participate in large clinical trials, what impact does it really have in the community? And then, of course, this focus on minority accrual. So I think this just shows you all the different components you need to really go from having a basic discovery to taking things into the patient and then into the community. You really need all these pieces. And again, with the structure of the DCI, we've been able to do that. As I mentioned, we opened this beautiful new building just a couple of years ago. Because of the way we're set up in terms of disease groups, we could set up, and we're responsible for patient care, we could set up our clinics that way as well. So all the clinics are multidisciplinary. It doesn't mean that every clinic session is multidisciplinary. The medical oncologists still, may have their own session, and the surgical oncologists have their own session, but there will be at least 1 or 2 days a week when they're all there together to see the patient. So, and so all the patients are co-located by disease type, and as I said, it has all the different disciplines. The Cancer Center building is quite beautiful, has all the services, including imaging, embedded in it. And then I'll end up by simply mentioning all of this is geared towards facilitating our ability to do translational research, as I mentioned, and clinical research. And we have a very robust clinical research program, about 1,000 active cancer-related clinical trials. We have between 6,000 and 7,000 new cancer patients each year. We have about 6,000 protocol enrollments each year, almost 1,000 of which are on treatment-related protocols. So it's a very robust clinical research activity, and it really encompasses all the different programs: solid tumor, women's cancer, radiation oncology, neuro-oncology. So all the different programs have very active research activities, and 2/3 of our trials are early phase trials, pilot, phase 1 or phase 2, so there's a big focus on that. Once it gets bigger than that, obviously you can't do it as a single institution, and then we're very interactive with the national cooperative groups in doing the larger phase trials. And then I'll end by emphasizing sort of the infrastructure that I keep coming back to, the things that we've set up that allow our investigators to do these kinds of translational and clinical activities: the biobanking, centralized genomics, these PDX tumor graphs, genetically engineered mouse models that can be generated if you know what gene you're trying to target. We have animal imaging so that when you're doing your preclinical studies, again, you don't have to develop your own imaging modalities. This is particularly important for genetic models of cancer rather than doing xenografts where you have the sub-Q and you can measure the tumor. Many of the best mouse models of cancer now are the endogenous genetic models, and for that you need imaging. We have extraordinary pharmacology that allows us to figure out how to dose and schedule the drugs in the mouse and sometimes dog models, the clinical trials expertise and infrastructure that facilitates what our investigators do, and then the outcomes research. The last piece is that if we have such a focus on clinical trials, we realized we really needed to be attractive to industry, to pharmaceutical companies and to biotech, so that they would want to bring their drugs to us so that we could test them in patients. If they're drugs that we develop, that's one thing, but if it's drugs that are targeted drugs that are being developed by someone else, we want to be attractive. And what attracts pharma? That you open up trials quickly. So we've worked very hard to become one of the fastest in the country in opening up new trials, and this is by investing in our infrastructure. And that then returns the investment, because then those trials come to us. We get the income stream from pharmaceutical companies and biotech to continue to fund our infrastructure. We're able to offer those drugs to our patients, and so it's a self-fulfilling prophecy. So the way we operate now is with these 4 sources of funding. NIH funding, which is a very big part of our basic and clinical research. I told you that we do have a formula with the hospital by which health system margins do come back to support some aspects of the DCI. We have partnerships with industry, and we have philanthropy. But we're always looking forward to the future to see, how do we continue to do what we're doing or do it even better. We all know NIH funding has gone down, and it's not going to be going up anytime in the near future, though the Duke health system has been historically quite healthy. We all know that healthcare reform is going to be negatively impacting on that, so our hospital margins will be going down sometime in the next 3 to 5 years, if not sooner. So therefore, we're focusing on these other 2 areas to make up those differences by having more robust partnerships with industry, both at the basic research level as well as the clinical research level. I just gave you the example of how we're doing this in clinical research, so that we want to be a good partner for them in testing their new drugs by having the infrastructure and being quick, but also to be very attractive in philanthropic efforts. And so I actually have to devote about 20% of my time now for the philanthropy component of this, because that's really the only thing that's going to make up the differences in the other components. So I will stop there and be happy to answer any questions.